natural log 3, and then equals, let's see, what was over here still was 2 natural log 3, and I'm bringing over what to this side, to the right side? 2 natural log 5, and it'll be plus, right? Almost. Almost. The whole idea of getting all your x's on one side is so you can factor an x out. These both have an x? Okay, so factor an x out. You'll be left with natural log 5 minus 3 natural log 3 equals 2 natural log 3 plus 2 natural log 5. No, because a natural log is not a number, right? Can you do what?
Oh, wait, no.
Factor 2 out of these? You could, but just hang tight. We're going to do something even better in a second. Here's x, right? I'm trying to solve for it. Everything else is a number. Do you agree? Natural log of 5 is a number. This is a number. All this is a number. That's a number. So everything else is a number. So to get this by itself, I'm just going to take everything in parentheses and divide it on both sides. When I divide everything in parentheses on this side, it goes away. Leaves me with the x. And on the right side, I'll just have everything that was already here divided by what was in parentheses there. Natural log 5 minus 3 natural log 3. That's what x is, right? Now, I am going to use my calculator to figure out what that is, but let me try and clean it up and see if you can follow me on this. X is natural log 9 plus natural log of 25 over natural log 5 minus natural log of 27. So what did I do? 2 came up on the 3, 3 squared is 9. 2 came up on the 5, 5 squared is 25. Nothing here. 3 came up on the 3, 3 cubed is 27. Understand? I'm going to go even further. In the numerator, I can make these two into a single natural log, couldn't I? That'd be natural log of 9 times 25. Well, what's 10 times 25? 250, so, right? So it's what? 225 over, what can I do here? 5 over 27, couldn't I? So I'm turning these, both of these into single logs using the condensing. This one is multiplication, this one is division. Can I do these into a single log?
You probably could. Yeah. That would be 225 minus. Well, yeah, it'd be only 225 minus 5 over 27.
I'm setting you up for that. I was trying to get you to make a mistake. Remember, I'm trying to help you not make this mistake on a test. Okay, remember the property is that if you have natural log of x times y, that splits into 2, right? If you have natural log of x over y, where the x over y is the argument, then you're allowed to split it up, right? But if you have 2 natural logs like this, there is no formula for that. So you just have to get on your calculator and do that. What is the whole thing?
Negative 3.21.
3.21. So we got at least 2 people in here got 3.21. That's.
It's negative.
Oh, it's negative 3? I think you said that, and I just totally ignored it. You're welcome. How we doing?
So for the top one, you just multiplied it, right?
I used this property right here
Oh, okay.
to here. The bottom one was here to here. But this one, there is no property for. So you just have to do it on your calculator. Okay? All right. while I'm thinking about this, before we do our next problem, I'll show you something. Well, yeah, we have one more type. This ought to be a good one. When I first started working here, I worked with this guy in this office. We were out in those little portable buildings. I don't know if you've ever seen those. That was my office when I first started here. And he had given me this problem. I don't know why. He just gave this problem to me to try and figure out. So x raised to the x 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 forever equals 2. Solve for x. Okay? All right, so it looks pretty intimidating, right? Let's just remember, though, x to the x to the x to the x forever needs to be 2, right? That's what we need? Okay, so now, if you look at this right here, that keeps going forever, right? What I'm going to do is I'm going to take natural log of 2 on, natural log on both sides of this equation. When I take the natural log of the left side and then natural log of the right side, this I'm going to pop out in front.
X with a line over it.
X with a bunch of x's forever, okay? So do y'all understand what I'm doing? So this is x to the x to the x forever, right? Times natural log, what? X must equal natural log 2. What? No, I'm just showing you something real quick, yeah. It's just something you could do, you know, on the weekend, you know, when you're just hanging out with your friends type thing. All right, but this x to the x to the x to the x forever actually is 2, isn't it? I mean, that's what we need x to the x to the x forever to be, is 2. So what I'm going to do is I'm going to replace this piece right here with 2. And you get natural log x equals natural log 2, like that. You with me still?
Yeah.
I'm going to pop this 2 up here.
Divide that probably by natural log.
So I'm looking at this now. Natural log of x squared equals natural log 2. And I'm going to use the property that we have the log on both sides. These two must be the same, right? So x squared must be 2, which means x must be root 2. And not negative root 2, because you can't raise negatives to negatives to negatives. It wouldn't work. So the answer is root 2. So if you take, it's impossible to do this, okay? But if you were to get on your calculator and do like, what's root 2 to the root 2? So what's the square root of 2 raised to the square root of 2? See, does anyone want to try it on their calculator, see what they get? No? You don't want to?
Right.
Let me try it. 2 root raised to the 2 root. 1.63. Now raise that to the root 2 again. 2 already? Like solid 2? So it already converged. Wow. It goes fast, I guess. Depends on how many decimal places. Let me try mine raised to the 2 root. Yeah, mine goes 2 already. But it's rounding. There is some rounding error in there. But if you were able to do it, 2 to the root 2, okay, if you were to do it forever, that's what it would go to 2. It's weird. Okay. That was just to kind of break our train of thought for a second so I could start this next type of problem. This is the last type of problem that you'll see in this section. And you're going to love it. What? 4 to the x minus 2 to the x minus 12 equals 0. You're asking me if you can combine these two together?
Yeah.
That's subtraction. You would have to figure out what this is and this is before you could subtract, right? So same with that 8 and the 3. Can't put those together. Can't put the 4 and the 2. These are good questions, though, because Usually when students don't quite know what to do, they'll try things that they think are true. Now, this is similar to the last problem in the sense that we do have two terms that have x up there, don't we? But the difference is we actually have a third piece, which is just a number, right? So maybe you're thinking take it to the other side. Maybe, but let me write it down. Don't write this, but let me see what would you want to do if you took that?
Well, you could do the natural log.
Okay, so let me try this. It would be natural log of 4x minus 2, 4 to the x minus 2 to the x equals natural log of 12, right? That's what, I agree we could do that. But could you pull the x out here? No, because this is not something, the whole thing raised to the x. Can you split this into two logs?
Yeah, that's what I was thinking. Like,
What's the operation? Subtraction?
yeah, so it'd be a fraction.
No, be careful. Go back to the properties. Division inside of a single log becomes subtraction of two logs. We do not have a formula when the subtraction takes place in the log. It does not split to anything. Just like we do not have a formula for when there's addition inside of a log, it does not split into two. So do you see that this is a problem? Yes? Okay, so what do we do? Well, let me show you. That's why we're here, right? I'm here to help you. Someone helped me, now I help you. All right? So you have to squint your eyes a little bit to see this one. Let me see. I'm trying to figure out how I want to do this. Do you agree that this is this? Do you agree with that?
Yeah.
Why? No? What's 2 squared? That's 2 squared? Isn't it? No, now hold on. Now, if everyone agreed with me on that, right? But just on the side note, what is 2 raised to the 2 raised to the x? What do you do with these two? Multiply them. So that's really 2 to the 2x, isn't it? Yes? Uh-huh.
So should I be writing this or not?
Yes, this is a problem that you'll have to do. Is that okay? Yes, this will be a test problem for sure. Something like this. Okay, so everyone agreed that I could rewrite 4 as 2 squared. And then on the side, I'm just reminding you that 2 squared to the x is really 2 to the 2x, yes? But is this the same thing? 2 to the x squared. What is this? Is that this? What do you do to these two? Multiply them, right? X, right? Times 2 is 2x. That's the same? So what I'm trying to get you to see is that these two are equal, aren't they? 2 to the 2 to the x is the same as 2 to the x to the 2. 2 squared raised to the x power is the same as 2 to the x power squared. And now I'm going to use this right here to rewrite this as 2 to the x squared minus 2 to the x minus 12. Does anybody see it yet? What is this? How am I going to solve this? What does that kind of look like? It kind of looks like a quadratic, doesn't it? Do y'all see it? Substitution. If I were to have come in here and just said, hey, look, let's just call this whole thing u, it would be u squared, wouldn't it? Minus this whole thing, 2 to the x, is the u, isn't it? Minus u minus 12 equals 0. Do you see it? No? Okay. No, I'm going to keep writing and then we'll see. We are at this line right here. I wrote over it in red, so I'll rewrite it. We are at this line, 2 to the x squared minus, I think I'll put this one in parentheses to really stress what we have here. Nathan, were you okay with at least that much? That 2 to the x squared was the same as 2 squared to the x?
I got that, it's just
Okay.
how you're able to see that breakdown like that.
So I'm going to write down here, let 2 to the x be equal to u. I'm making what's called a substitution. It's very common in mathematics. We get a problem that's very complicated looking. We make a quick substitution to make the problem look doable. So 2 to the x is u, right? So I'm going to rewrite this as u squared minus 2 to the x is u, right? So minus u minus 12 equals 0. Now forget the whole 2 to the x thing and just look at that. That's a quadratic, right?
Yes.
Does it factor?
Yes.
Minus 4, no.
Plus 3.
Is it? Yes. Minus 4 plus 3. U minus 4, u plus 3 equals 0. So solve each one, and you get u is 4, and u is negative 3, right? Yeah, but this is now you have to go back, okay? So it's, at this point, if you were to get this on a test, it would be like me asking you what your favorite color is, and you're like, Ford, you know?
Yeah.
Dodge, or, you know, it's like you're not even answering the question. We're asking what's x, right? And you're giving me what u is. That doesn't make any sense.
Well, now we have to bring that.
So you have to bring this back now. Okay, so this substitution was only to help us see it's quadratic. Now we go back. So what was u? U is 4, right? But u was 2 to the x. So 2 to the x is 4. And then the other equation was u equals negative 3, which means 2 to the x equals negative 3. No, because we do the loops on the logs, right? On log equations. I want to solve for x. X is up in an exponent. What do I do to drop it out? Bring the natural log on both sides. That one I could just look at and tell the solution, though, right? X is 2. 2 squared is 4. But I'm going to do it, you know, using the technique. So here, natural log of 2 to the x equals natural log 4, which means x natural log 2 equals natural log 4. And divide both sides by natural log of 2. And then you do that on your calculator, you should get something really close to 2. How about over here? Can't happen. X natural log 2 equals natural log of negative 3. Not happening, right? Can't take a natural log of a negative number. So there is no solution here for this part. So your only answer is 2. You will definitely get a quadratic type problem like that on your test. Nope, doesn't have to be. Let me show you. Let's see. Taking a look at what your homework goes up to. What the heck? 50s. Yeah, let's try one more. How about 3 to the x minus 14 times 3 to the negative x equals 5? So again, this one might take a little while. You look at it, you're like, what the heck, I can't see it, right? So I'm going to help you with this one, just so, you know, first time through. And the last problem, we rewrote 4 to the x is 2 to the 2x, right? We can't do that here. They already have the same base, don't they? 3 to the x. It's just, it's not quadratic because this is not double that, right? Like quadratic, we need this to be like a 2 and this one to the first power, yes? So instead what I'm going to do is I'm just going to rewrite the problem and just tell me if you agree with this, whether or not this is the same thing. Whoa. 3 to the negative x, you have a negative power, you drop it down, right? So that's fair? Now what I'm going to do is I'm going to clear all fractions. So I'm going to multiply both sides of this equation by the LCD. So what's the LCD? 3 to the x, right? So I'm going to multiply the entire left side by 3 to the x, the entire right side by 3 to the x. Not 3x, right? 3 raised to the x. What is 3 to the x times itself? 3 to the x times 3 to the x. Isn't that 3 to the x squared? Yes? This is 3 to the x squared. Right? Then, when I multiply here to here, what happens to the 3 to the x on top and 3 to the x on the bottom? They cancel, you're left with just minus 14. And then on the right, what's 5 times 3 to the x? Yeah, that's right. You can't do that. See, it's 5 times 3 to the x, whatever the hell that is, right? Do you see what we've done? This now is going to look like a quadratic. If you squint your eyes, this is the u. Do you see it? U squared minus 14 equals 5u. Right? See, look, 3 to the x is u. U squared minus 14 equals 5u.
So you bring it all over to the...
Yeah, so I'm going to let, I'll bring it over in a second. I'm going to let u be equal to 3 to the x. And then I rewrite the problem, this one, as u squared minus 14 equals 5u. Do y'all have any questions on that part? I mean, that's like the most important part of the problem. Well, second most important. Clearing the fractions is the most important thing. Bring everything to one side. U squared minus 5u minus 14 equals 0. U minus 7u plus 2. Two solutions. U is 7, u is negative 2. And now replace u with 3 to the x. So 3 to the x is 7. 3 to the x is what? Negative 2? Which won't work. That one you can chunk right away because you know when you take natural log on both sides, you're going to be stuck on the right side. This one, though, natural log 3 to the x, natural log 7. Drop your x down. X natural log 3 equals natural log 7. And then divide. So whatever natural log of 7 divided by natural log of 3 is your result. Anyone? Sure. 1.77. Any seconds on that? Okay, 1.77. For what? Phone a friend? Phone a Wolfram Alpha? All right. Well, here's our plan. Like I said, I emailed you with an attachment last semester's exam 3 as a guide as to what to look at. It's not limited to that. I think in the email I said make sure you look at your homework, look at the problems that we did in class, and then take a look at that exam. And then next class we still have one more section to cover, which is going to be applications. 6.8, and what we're going to look at are like exponential growth and decay models. So I think I'll probably do some population growth, some bacterial growth. I like Newton's law of cooling. Newton's law of cooling is usually one that people like, because it's like Newton's law of cooling works like this. Y'all can pack up. You have somebody, I don't know what the way things are these days, if this is right to talk about, but you come into a room, these investigators find a dead body in a room, right? And so they use Newton's law of cooling. What they do is they take the temperature of the room, and then they take temperature of the body, and from that they can model how long the body's been there, like how long it's been since the person died. And that's called Newton's law of cooling. And so what we could do is we could just make up some hypothetical information and figure out how long someone's been deceased. So we'll do some applications next class, maybe 2 or 3, and then we'll have the test on Monday. Okay?
Is that like the hot rock problem? Where they have like a hot rock and room temperature water, you can see what time it takes to equilibrium?
Yeah, that's pretty much the same thing. Now they're putting it in